I'm on right now. I'm going to ask if everyone in the chat can hear me. Just go ahead and say hello. If you can hear me just fine. We already tested this beforehand, so we shouldn't have really any problems. All right, perfect. All right, without further ado, let's start. Hello, everyone. My name is Wyatt Phillips, and we're going to be embarking on a web scraping workshop in Python. This is really exciting. It kind of goes over different topics such as data science and data extraction. So, who the heck am I, first of all? Oh, okay, I just went gray for a sec on my other end there. I'm kind of watching on my third monitor just to make sure that the live stream is working okay. Anyways, who am I? I am a junior at Wentworth Institute of Technology here in Boston, studying electrical engineering and minoring in computer science. Although my experience with coding goes a long way with skills in front-end and back-end frameworks, languages such as Java, Python, JavaScript, and just recently I embarked learning about data science, one just as a hobby, and two for my current internship. Right now, during the winter semester, I am on my winter co-op interning at a marketing firm called C4 Analytics as an associate programmer, kind of mostly working on web scraping applications for them to gather information in the automotive industry. And of course, on the bottom, you'll find my email and Discord tag. I'll be on Discord throughout the entire hackathon period. Feel free to always message me if you have any questions regarding about web scraping or just anything in general. Alright, so let's talk about the theory for a sec. Data is pretty much a huge weapon right now. It is tackling many different problems, including the COVID-19 crisis, and this is important because a lot of this data is being sourced from different sources. We're making APIs for it, and we have data sets on Kaggle. If you don't know what Kaggle is, by the way, great website. I would check it out. It contains a lot of different CSVs for like different sources of data, from car crashes to, of course, the cases by country for the COVID-19 virus. And that kind of goes into the point of saying there are many different easy-to-use APIs and CSVs out there that you can just import into your application. I know that there are a lot of APIs that were talked about in different workshops, and they all kind of center around gaining information in a certain format. Like if you want the weather, for example. I am not lying. There are already many different data sets out there. Hold on a sec. Sorry, I'm just looking at the chat. It can't provide a secure connection. I would just go ahead and at this point reset your computer, Halt Wizard. And we're going to be using Beautiful Soup, not Scrapey, for this. I'll try my best to answer questions. I can't promise that I'll be looking at my third monitor. I'm mostly just kind of focused on it going from point A to point B, but if you have any technical difficulties, I just want to make sure we get them straightened out. We're going to have to open up a Google Colab notebook for this, and I would recommend using Chrome. I already sent the links out. If you have any trouble, just let me know. But going on about that point, if we can't use API endpoints and datasets to get our data, then what do we use? What about the websites that contain all the raw information in HTML? And that's when we need to extract the internet for our data. There are, debatably, there's more web pages than there are actual data sets. And that's just mostly because people want to upload it so that humans can read them, not machines. People like us, where we have it formatted, we have the CSS to kind of move things around, we have HTML structure, but other than that, without kind of using parsing, we can't really make any use of that HTML jarble, and it's useless for our application, and that would be you. So we don't want that. We want to be able to extract our data, and we want to be able to format in the way we want to, so we can export them as the CSVs and pretty much everything like that. And the biggest problem is that data on web pages is not consistent, or it's not continuous. There is no table structure. You have to kind of play around with it, and I'm going to talk about the different methods you can use for that. So now that goes to the tools and frameworks that we actually put into place when we are scraping. Now notice we are using Python and Beautiful Soup. Those are the actual images that you should always use when you refer to Python Beautiful Soup. That is just the correct programming lingo. That will allow us to read the web pages, kind of like pick out patterns, generate our tables, and then save them. We can also, and then later on, we can use them in our applications or perform some data analysis to create some new insights. All right, that's really it for the theory. We're going to actually start going into we're going to get our hands dirty right now with Colab. I don't want to use Python just because a lot of people are going to have trouble with it. You have to install some packages, and Google Colab actually already has those packages installed. You don't need to perform any other commands here. So it's all in the cloud. This is actually a really great tool, just in general. I discovered it recently, pretty much last night. So it's essentially a Jupyter notebook that runs in Google Cloud. And what that means is if you ever used Jupyter before, it's pretty much essentially like a Python notebook, and you can run different blocks of code. So go ahead, click on this link, collab.research.google.com. I'll actually just go ahead and, darn it, I'll go ahead and put it in the chat here so that you can just access the web page in general. If you want to go to the workshop notebook, I provide that in the Discord. If you can't get the chat for some reason, just go ahead and copy it. I'll give you like a moment to do that. In the meantime, I'm just going to type in... if you just want to start from scratch entirely, I mean, you can start from scratch just from the notebook link itself. But just in case, you never know. It might not work. You guys spelled that right? Okay, sending that. So you should see it in Twitch right now. Like I said, I'll give you some time to open it up. Make sure you click on this link, shorturl.at. That should be found in the Twitch chat. If not, go ahead and copy it into the URL. Okay, I'm going to go ahead and go to that right now. One more thing. If you do want to use standalone Python for this, just in case, just for your application or whatever, you can, as long as you just install the 4 modules ahead of time. You can do this by going into your command prompt or terminal and type in pip install requests Beautiful Soup for NumPy and Pandas, and make sure that installs. If you have problems, just use the Colab notebook. It's going to be a lot easier and more interactive. Let's go into it. I already kind of created this final version. We're going to start from scratch so I can go over it step by step. You'll see that we have a lot of import commands. We're kind of parsing the HTML using Beautiful Soup. We make it a soup object. We have to perform a kind of... we have to do a bunch of mapping here. I'll try my best to explain it, but this is just the easiest way so that we can put it in one line of code. Like I said, all you really need to know are like the selectors here. And then we're going to take our data frame. We're going to just make sure we map the categories to the top here. And then we're just going to export it as a CSV. All right. So the website that we're going to be extracting information from is worldometers.info. This is a very relatively easy site and usually a hello world of web scraping. I've seen a lot of other people in tutorials use it. In this case, we're going to look at the coronavirus pandemic page. This is going to contain all the cases by numbers, deaths, recovered, and most importantly, this table that sorts it by country. And we have a lot of fields here: total cases, total deaths, new deaths, total recovered, all that kind of stuff. So, like I said, this is already a gold mine here. There's a lot of data that we can use, whether it's for a front-end application or just for data science in general. It's a shame because we really can't export this as a CSV. There are no buttons to download it. They didn't provide us with a data set. It's just HTML. But if we use web scraping skills, we can get all this data and format any way we want. So I'm actually going to, before we go into the pattern analysis, I'm going to start by typing in the commands. If you are in the Colab notebook, you're going to click on File, which should be a tab. You should be able to see the tab, by the way. If you don't, just let me know in the chat, and click on New Notebook. This is going to open up a new Python 3 notebook, I believe. Perfect. And I'm just going to follow along too with the final code as well, just so I'm not typing anything in wrong. Perfect. So the first thing we want to do is import our libraries. In Python, you just type in the keyword import, numpy as np, then import pandas as pd. And in case you're wondering, if you use the as keyword in an import statement, it just basically means, okay, we're going to refer to the module pandas as PD. So when we call it later, all we have to do is type in that short abbreviation for it. So we need to import requests. This is going to be the request library that allows us to fetch web pages. It will work in Google Colab. If you are running Python, there's a problem. It might have to do with kind of like if you have a proxy set up or something along those lines. Like I said, just if you use a Google Colab notebook, it should be relatively painless. Okay, I just moved the Twitch live stream on my second monitor just so I can see it. And then last but not least, we're going to type in from BS4, that just stands for Beautiful Soup 4, import the that's weird. Oh, maybe it didn't. Okay, I hope it's in there because it has to be. It's a Google Colab notebook. Let's just go ahead and run this. By the way, in order to run code, you can either click on this play button next to a cell, or you can hold down Shift and press Enter. Just pressing Enter is just going to create a new line. That's something you should definitely note. If you hold down Shift Enter, it runs a cell. And by the way, everything I'm saying right now applies to a Jupyter notebook as well. So if you want to use Jupyter notebooks, maybe when you're learning about data science, like all those macros kind of apply too. This is a really cool resource that Google provides. It's essentially used to do really huge machine learning or computational analysis, which is why we can buy RAM and more disk space. All right, let me stop rambling. We're going to go ahead and fetch our page. We can do this by assigning a variable rec equal to requests. By the way, you can it auto completes the code, which is awesome. .get, and this is going to take in a URL. We want to take in this URL, and that's really it. You can provide more arguments if you want to, but that's for more advanced users. Go ahead and click on Shift Enter. If it runs okay, it's not going to return anything. We can actually go ahead and look at that response object by typing in rec, Shift Enter. You'll see that says response. That's the object. It's not going to just right away return the HTML text. There might be other information we want, such as the status code. If it says 200, everything's working a-okay. I highly recommend BS4. Selenium is more of an automation tool, or per se a headless browser. So you want to use Selenium in conjunction with a web scraping framework. Otherwise, start with BS4 first. It's a really easy to use Python library, and once you're confident, go ahead and use Scrapy. Scrapy is really awesome for kind of like organizing spiders and crawlers. I won't go into that in the workshop. It's just there's a lot of information covered. There are Udemy courses on it. All right. So we have the 200. That means everything is working a-okay. We can call different methods or look at variables from it. The one I'm more interested in is content. And that is going to return all of the HTML. It's pretty much unreadable. Like, we can't interpret it as, like developers, or the machine can't interpret it. We need to parse it. And that's when Beautiful Soup 4 comes into play. So I'm going to go ahead first delete these cells. We're going to go ahead and assign a new variable, and that's going to be soup. And we're going to set that equal to a Beautiful Soup method or constructor. Kind of forgot. Need to touch up on that. Rec.content. Okay. So if we do Shift Enter, if you don't have anything returned, that's usually good. I'm going to go ahead and type in soup. I don't recommend doing this because it's going to spit out a lot of text. I'm just doing it for demonstration purposes. You'll notice that we still have the same exact HTML, except now it's prettified. So it's nicely formatted, and that's kind of like going into the intricacies of Beautiful Soup. It essentially makes a structure out of that HTML, and it's able to interpret like the document object model, or DOM for short, and it's able to kind of like locate different elements. And it's going to be useful when we want to use selectors. I'm going to go over that when we go back to the page. But if you were unfortunate to actually run this, just go ahead and delete the cell. You'll have to scroll up a little bit. Okay, so now we have our Beautiful Soup object. The hardest part now is going to be pattern recognition. So I'm going to go back to the website. We're going to just look at this table for a sec. If you are in Chrome, I think Firefox will work just the same. We're going to go ahead and right-click on China, and you'll see Inspect or Control-Shift-L, I believe, or I. If we click on that, it'll open up this little tab. This is the Chrome Developer Tools. It'll show us basically the HTML structure. And we can already see the A tag that represents China. It's enclosed in a TD tag. And this is just representing the entire cell. But what we need to do is we want to iterate for each row in this table. That's kind of like the way I'm seeing it. This is a table. Each row will be its own object. And enclosed in that is a table body. But it just says table body. There's also the table head we want to take into consideration. Let's go up a parent. Now you'll see that everything here is enclosed in a table object. And the best part is, like, what we want to do in order to make this distinct is look at all the attributes. We already see that there's an ID. This is a fortunate scenario we find ourselves in where it has an ID. It's going to be distinct across the entire HTML page. It'll say main table countries yesterday. If you have now selected, it will say main table countries now. I have to go ahead and inspect that again, because there's like two different tables, and they're visible whenever you click on the hyperlinks. Wait a minute, what happened? Oh, there's the table. So there's also main table countries today. So we can use that towards our advantage. I'm going to go ahead and talk about CSS selectors. These are very useful for when you want to select certain tags in the HTML. And what we can do is if you hold down, press Control F when you're selecting the HTML. Control F should open up this Find tab, and you can type in a string, selector, or XPath. Keep in mind, we want to put in a CSS selector. I provided a link in the notebook that can link you to a cheat sheet on that, giving you XPath and CSS selector help. So we're going to type in table. And the first thing that pops up is that we're going to find any tags or just anything in general that says table. That's kind of a problem. So already it's not distinct. Now let's put a pound sign. This is just saying anything that comes after the pound sign is going to be an ID. So let's find all the tables with an ID of main table countries today. Already, we only have one result. That's good. If we have 1 out of 1, you're already on the right track and you're selecting your table as is. It's selecting this entire table. All right, perfect. Now we want to just we want to select each row because we want to at the end have an array of rows. In each element in that array is going to have its own array of cells. So let's select it by row. Just bear with me. This is a little bit confusing. All part of the web scraping process. I noticed that every row is enclosed in a TR. To select a descendant of a tag, press space and type in TR. Now we have 201 results. And that will refer to every single row in this table. If you hold down enter, it'll just iterate for everything, highlight everything, and we keep going down and down until it just goes back up. So it sounds like we don't have any mixed messages or different occurrences of this TR, because remember we enclosed it. It has to be a descendant of that table in general. So we're done with defining our selector for the rows. We're going to go ahead and copy that for now. And what we're going to start doing is, to explain what I'm about to do, we need to create an array of arrays where the cells are actually just text. If we call, I'm going to go over how a selector works right now. So we have our soup object. Type in soup. In order to select certain tags that represent our CSS selector, we do soup.select. And we can basically put in our CSS selector. That's what it's called. It's going to return an array of all things, or all tags, that match up with that. And we should have 201 returned to us. So I think this is all good. Let's press Shift Enter. And you'll see it returns more HTML, only to find that it's, if we scroll up, you'll notice that it starts with an array bracket, and every single kind of row is separated by a comma. So now we have an array of each kind of like divider of HTML. However, that's not good enough. In this case, we need to now iterate through all of this, and we can use what's called mapping to iterate through all the elements in an array in just one line. So I'm going to type in list map. And that's just essentially basically saying return an array where we're iterating through everything that comes from an array we just made. So the second argument, I know I'm kind of going backwards here, but a map is just essentially taking an array and for each element applying a function to it. In Python, any one-line functions are called lambdas. I know it's a lot of information to take in, but if we do lambda x, x is going to be every single element in that array, and it's going to replace whatever elements were in that array before with the function itself. So if we just type in x, it's going to just take every element in our soup select array and just essentially return the same thing. We don't want to return the same thing, though. Instead, we actually want to select our cells. And for that, we actually have to analyze this a little bit more. In every row in the cell, we're going to have a bunch of TD tags, and that's just going to represent each cell within a row. And that's perfect. The only unfortunate thing, in some scenarios, this might be bad, where you don't have any sort of attributes to define it as is. So we, without knowing this is a table, we can't really tell what value this belongs to in a field. Like you'll notice that this is the total cases cell. There's no attributes that label it as a total case. But this is a table. Remember that. So if we're working with divs instead of tables, it might be more useful to know where that is, but this is just always going to be in sequence. There's going to be always the same amount of TD tags for every TR tag. That's great. So we can just literally concatenate that into an array of cells, and then we're going to apply our columns later. We just need to recreate the table, per se. We're just assuming it's going to have the same format. No TD cells are going to not be present. Let's go back to our notebook. We're going to go ahead and type in x. We're going to put this into a map list. Now we need to call the map again in a map. So that the reason why we're doing this is because even if we return all our cells as an array, we need to get the text from it. It's only going to return a tags as well. I'm going to demonstrate this. If we do we're going to do x.select again. We're going to actually just put in our, there is one thing. We need the TDs, but we also very much need the THs. And the THs are found in the titles, or the columns, or the column headers. Otherwise, we're not going to pick it up. We are going to pick it up anyways, but as an empty array. We just want to inherit all of these titles, so it'll make it easier for us to make our data frame later. So we want TRs and THs. The way we can select both tags instead of it being descendants is by we type in our first tag that we want to look for, then we separate with a comma. This just essentially means find both TDs and THs if they're descendants of this tag. Let's go ahead and just press Shift Enter. See how this is looking for us right now. Oh my. I hate scrolling all the way up. I'm really sorry if I'm making you having to like press Shift Enter. Okay, this is good. We have an array of arrays now. The only problem is all of them are still enclosed in HTML tags. We don't want that. We actually want the juicy stuff inside of it, the data. And we can't do that without calling another function. That's why we have to use list.map again. And I'm going to just go ahead right now and enclose that in list.map. I promise this line is going to be the only difficult thing in this course, or this workshop. The second argument is going to be that array within the array. And we're going to do another lambda function. We're just going to call it y this time. Going to represent, the y is going to represent each line here. We want to call y.text. In other words, what this beautiful soup function does is, okay, take the actual contents, don't return necessarily the HTML tags, just the content. And I think that's it. If I go ahead and do Shift Enter again, it's invalid syntax because I typed in lambda wrong. Yay! Let's do that again. Okay, beautiful. So, if you don't notice what's going on, we have the array of arrays again, except now all that HTML tag gibberish is gone. And now we have all of our raw data. From China, Italy, United States, this looks perfect. And the first element is going to be all the header names. Hold on a sec. I'm just looking, like I said, I'm looking at the Twitch live stream as well. Yeah, okay. Suiku, thank you very much for making that point. Yes, you could probably press Control Up. I didn't know that. Yeah, because we're selecting, we can select different cells too. Okay. Anyways, finally, last but not least, we want to set this as a variable. So data equals list. Now we have our data, that's an array of arrays. If we type in 0, for example, that will give us the first row, which is our headers. And if we do another 0, it'll give us the country. If we go to the first one, it'll say China, second, Italy, third, United States, and so forth. Okay, now what we need to do, this is like the second to last step here. We're going to go ahead and turn this array of arrays into a data frame. Now, data frames are a part of Pandas, which is a data science library. It allows you to manipulate data and kind of do some analysis or kind of like calculations. And the biggest feature of Pandas is the data frame, which is just made up of a bunch of series, and it all follows the foundation of NumPy. So let's go ahead, type in df, that we're just going to make a new variable called dataframe, or df, is equal to pd. Remember that we refer to PD when we want to refer to the pandas module, data frame. This is just essentially saying, make a new data frame based on the data we feed it. And we can just feed the data as it is, because it's an array of arrays, it'll take it just fine. Let's go ahead and press Shift Enter. It returns without errors. If you do have any errors during this, I recommend you look at the final notebook. If you are really still having problems, because this is all on Google Cloud, just let me know. I'll be more than happy to answer any questions. So, let's put this side by side. We have our data frame. It is beautifully formatted. It will have our headers, all the countries, and the data matches up pretty well. If we go ahead and look, we have, did I do yesterday or now? I think oh, wait a minute. Okay, that's a little weird. Oh, okay, never mind. I was kind of reading it wrong. Yeah, we have 81,285, 74,386. So all matches nicely. The only problem I'm seeing is our headers are actually numbers. Pandas data frames, like when you first create them, they don't know. They're not going to assume your first row is the actual headers. It's going to just make it as another row. We need to basically tell pandas, okay, this first row is the data frame. And the only way we can do that is actually setting it manually. So we need to do df.columns. This is actually going to return all the columns. It's a range index right now because it's all numbers. We need to change that. We're going to set that equal to df ILOC. This is just saying by default, pandas data frames the index always refers to each column because it's kind of like a key, a dictionary almost. So if we do ILOC 0, it's going to essentially say return that array of the first row. Okay, press Shift Enter. If we look at df again, you'll notice that now our headers are what they should be, except we still have that row, which is the same thing. Essentially, we want to get rid of it. To do that, we can do df.drop. This is a function in pandas that allows you to drop rows or columns. We just pass in that index 0. And because you can do both, we need to specify the axis. By default, it's 0. I'm just going to type it in anyways, just for the sake of showing you. Basically saying, remove the first row because axis is equal to 0. That refers to rows, not columns. Type in place equal true. That's essentially saying, because we're not assigning it to df, we want to just, any changes that we make to the data frame, we want to apply it to the original data frame. If we did in place equals false, we would have to do df equals, but in this case we don't because we have in place set to true. Press Shift Enter. Like I said, no problems occur. Look at df again. That column is gone. That row is gone. It starts with China, Italy, US. This is pretty much a same match here. And just to show you how easy it is to apply this to your own project, if I want to look at yesterday's data, I can just inspect that. I want to get the ID. I have to actually open this up. Okay, go ahead and inspect it. Go ahead and find a table. Oh, God. You know what? It's just probably underscore yesterday. Yeah, it is. Okay, great. So we're going to go ahead and just change this. It's as simple as changing the selector. Go ahead and replace that with... Well, you know what? I actually wanted today, not yesterday. That's why we're probably not seeing it. Okay, sorry about the technical difficulties. So go ahead, get to today's values. We're going to set that now to today. Yeah, there we go. That was really confusing for some reason. So we have it set to main table countries today. Go ahead and run this again. We'll literally get the same table, except now we have the data from the other table. And this is just emphasizing the point of how easy it is to manipulate or like change what data you're looking at. So if we look at now, it's... Yeah, so like it changed as a table. Okay, that's a little weird. Whatever, but you kind of understand the point. Like to emphasize that you can actually change these selectors so that if you're looking at different data sets, all you have to do is pattern match it. And like I said, the way you do this is you just inspect a bunch of elements, kind of figure out what the parent for each row is, and make a CSS expression out of it, or a CSS selector. Like I said, I'm going to provide a link to it, but just for time's sake, I'm not going to cover too much on it because it's a whole advanced topic. It's a headache to kind of look at. and there are many courses on it. Like, web scraping is its own field. It's all part of data extraction. All right, we have our data frame. It's perfect. We have the headers where we want them to be, and all the data, there are 200 rows. The final thing we want to do is export this as a CSV. Maybe you are, if you just want it in Python, then you're done here. But if we want to export it, we can actually type in a function that comes with Pandas data frames, and that is the 2_ functions, or Python functions, and it allows us to just save a file from a data frame into any format we want. There's a lot here. We have Excel, CSVs. To make this easier on us, we're just going to export it as a CSV because most data frames are in CSVs. And we're just going to call it COVID-19.csv. And if we press Shift-Enter, if it does nothing, that means it's saved. This is a little confusing at first, but the Google Drive notebooks, they do have internal storage structures. If we click on the folder here, we'll actually see all of our files. Like, it's its own directory per se. It has a file system. That's why we have disk space. And we'll see the COVID-19.csv. The last thing you're going to do is right click on it and click on download. I already have like 2 of them on my in my downloads folder. Go ahead and click on it. If you have Excel, that's perfect. We'll see all of the data that we just got. Notice that we are able to replicate the table from the Worldometer website and put it as our own, format. And we have all 20 countries, including the total. You can manipulate this in any way you want, but like I said, I'm driving the point home where you can just change those CSS selectors. And like I said, there are a bunch of different resource links here. Oh, right, because I put them all in the final one. So yeah, we have a selector cheat sheet, which kind of talks about the different selectors you can use. We mostly, in our tutorial, we use the tags. We use descendant selectors, which is essentially saying, it's just basically saying, okay, find a paragraph tag that is within our div. This is also just saying only find it if it's a child, not descendant. There's a lot of them here. Doesn't setting the header afterwards mess up the auto detection of the series data type? I don't really think so, because like if you are using a notebook, you will you'll kind of have an idea of what it looks like. I don't entirely understand auto detection of the series. No, it shouldn't, because I think everything is a series. A series can take multiple data types in itself. That's just kind of the Python framework. And I have there's all of the documents to Beautiful Soup, Pandas, and of course the workshop presentation. Oh, and soup select. What does that TR at the end after yesterday represent again? TR is a table row, and that's how it's formatted in the page. So a table row is essentially this entire thing. We want to select each table row. We have an array of arrays. All right, I'm just gonna finish off this presentation here. So if you want to, if you kind of want to dive further into advanced web scraping, there are many different tools you can use. The one that definitely comes to mind, I saw a lot of people put into the chat, which is great, is Scrapey. And this is what I use mostly. I really haven't touched Beautiful Soup 4 in a while until I had to do this workshop. But Scrapey is essentially a spider. It's a spider manager. You can create multiple things called spiders that its job essentially is to scrape multiple web pages. And it can validate and extract the data, put it into databases, and so forth. And the other thing we were talking about too is XPath selectors. So we were using CSS selectors, which is just an easier to type format of it. But if you are scraping advanced HTML structures, if you want to scrape anything, you want to look into XPath. You can't, Beautiful Soup 4 by default does not support XPath selectors. There are extensions for it. I haven't been able to figure out how to use them already. And if you are using Scrapey, you will want to look into some cloud tools that allow you to manage your spiders. We have Scrapey Cloud. I use that. It essentially allows you to scrape pages in bulk. And there's also other services on the side. If you want to not get banned from scraping, because some websites, they will have policies against you from scraping, and they'll try to ban your IP if you're making too many requests. You can use stuff like Crawlera. That's a rotating IP. It's kind of like a really smart proxy. I just convinced our company to start using it, and I was able to scrape 1,800 different pages for automotive use. Red John, I've actually already shared the Jupyter notebook and slide. The notebook is actually going to be a link in the... No, I'm sorry. The slide is going to be a notebook in... the slide is going to be a link in the notebook. I kind of stayed up really late last night. So, I'm just going to go ahead and paste that short URL again. There you go. So, that's really... Oh, yeah, and one more thing. Validation and normalization play a big part in scraping. We want to normalize the data for our data sets so it's not always the same. This is a problem I'm having right now, where I'm scraping contact information for different dealerships, and the biggest problem is all the phone numbers are formatted in different ways. So I use regular expressions to kind of capture all the more necessary parts and just format it into a consistent format per se. Entity, you can download the CSV again by going to the folder icon. Oh, let me run this. Oh, I'm in the, okay, I'm not in the final one. That was kind of confusing. If you right click on the folder, if you see the CSV, if you don't, run this code again, but right click on it and click on download, and it'll just automatically download it to your downloads folder. Hopefully that helped. Obviously, let me know if stuff isn't working. Google Colab should be very easy to work with. All right, and that's pretty much it for my workshop. Hopefully I can do more of these. I know it's going to be a very long hack quarantine. We're on for 3 weeks. This is pretty awesome. With that, I wanted to give a special thanks to the hack quarantine team. All these people have spent many hours, numerous hours, putting all of the workshops and activities together, as well as a live stream. They're super helpful. They're very active on Discord. So just take the time, say thank you to some of the to the team. They would really appreciate it. They could use it right now. And that's pretty much it. I'm going to just answer the next set of questions, and I'll be off. How to extract text from those pages you don't know URLs about. Say Stack Overflow answer to a particular question, and the user can ask any question. So like I said, it's a matter of pattern finding. For stuff like, Stack Overflow, yes, you can scrape them. And like I said, if you go to any web page, the first thing I would do is right-click, click on Inspect, and just try to find a format for it. A lot of these dynamically generated pages are actually, they have a consistent format. My problem is I'm scanning multiple different websites where each format is different. So I have to think of a different way to scan it. There are many different companies that are trying to figure out the art of consistent scraping, but I haven't figured it out yet. It's like an interesting field. Everyone formats their text differently. Yeah, thank you very much, everyone, for all the thank yous. This is my first workshop in a while. So like I said, I'm already seeing that there are patterns here. Everything is within a div. There's it's usually followed by a class of answer. So if I want to, I can go find, do a dot answer. And you'll notice that every answer is selected here. And I can just click on enter, and it'll select every single one. And that's like the things you want to look out for, the attributes in the classes, because you can use them towards your advantage. And then if we go into that answer, we can then find out if you want to extract code, for example. Like I said, this is all user generated, so after, like, you'll have a pre-tag here, and you can kind of take in the pre-tag and extract all this text as well as the paragraph. So I could say answer P, and it's going to take every paragraph here. We can then put it into we can then kind of like put it into a data frame. So like I said, it's all about pattern matching, about using those CSS selectors. Okay, I think no, the user tells only the question.